In 1863, a New York billiard company offered $10,000 to any inventor who could save the elephants. Read that sentence again. A billiard company trying to save elephants, not out of love, not out of conscience, but out of arithmetic. The most popular indoor game in America was running out of raw material. Every ivory ball on a pool table required a chunk of an African elephant, and a single tusk yielded maybe 4 playable balls if the craftsman was lucky. The math was ugly, and it was getting uglier by the month as billiards boomed across the saloons of New York, Boston, Philadelphia, and every muddy railroad town in between. So Phelan and Collender, a Manhattan firm supplying tables to half the country, ran an advertisement offering a fortune to any chemist who could invent a substitute. Something moldable, something white, something an elephant could keep. 6 years later, a printer's apprentice from upstate New York walked into his workshop, spilled a bottle of solvent onto a scrap of treated cellulose, watched it congeal into something strange and glossy, and quietly began building the material that would change the surface of the planet. His name was John Wesley Hyatt. What he made was called celluloid, and it was the first plastic anyone had ever cooked out of a chemical vat and shaped into a useful object. The elephants, in the short term, caught a small break. The world, in the long term, did not, because 60 years after that moment, plastic would be everywhere, and a little over 60 years after that, it would be inside you. This is the story of the material that was invented to fix a problem and became a much larger one. Here is what makes this story strange. Plastic was not sold to you. It was not marketed at you the way cigarettes were with a wink and a cover story. Plastic arrived over the course of a century as pure good news. It was the material that saved the elephants, then the material that saved the tortoises, whose shells were being harvested for combs and hairbrushes, then the material that made pianos affordable for working families, because a plastic called Bakelite could substitute for ivory on the keys, then the material that let ordinary women wear the kind of jewelry that used to require whalebone or coral, then the material that made X-ray equipment possible, that made your grandmother's telephone possible, that made the radios possible on both sides of the Second World War. Every jump in plastic technology, from the 1860s until roughly the 1960s, was greeted as progress. And it was progress. Real progress. The kind you can measure in animals not killed, in items suddenly affordable, in objects that no longer broke the first time you dropped them. Nobody was hiding anything. That is the strange part. There was no smoke-filled room. The chemists were proud. The magazines ran glowing profiles. Time magazine put the inventor of the first fully synthetic plastic on its cover in 1924 and called him a hero of the modern age. His name was Leo Baekeland. Remember that name. We will come back to him. So how did the miracle turn into what a growing pile of scientific studies now describes as one of the largest chemistry experiments ever performed on the human body without consent? How did the substance that saved the elephants end up inside brain tissue on an autopsy table in New Mexico? The answer is not a conspiracy. It is something more unnerving. It is the story of an invention that worked so well, so cheaply, so quietly, that nobody thought to ask a very simple question until it was much too late. Where does this stuff go when we are done with it? They did not ask, and the material did not leave. Go back to the beginning. Back to Alexander Parkes in Birmingham, England, in 1862. Parkes was a metallurgist who had been fiddling with cotton and nitric acid. He had figured out that if you dissolved treated cotton in solvent and mixed it with camphor, you could pour the resulting goop into a mold and let it harden. He called the result Parkesine, unveiled it at the Great International Exhibition in London that summer, and immediately went bankrupt trying to manufacture it. His idea was ahead of its market, but the world had seen it, and John Wesley Hyatt in America had read the papers. Hyatt was working, remember, on that billiard ball prize. What he improved was the process. His celluloid, patented in 1870, could be pressed into shapes, colored to imitate ivory or tortoiseshell, and produced at a fraction of the cost of the materials it replaced. Within a decade, his factory in New Jersey was pumping out combs, dice, dominoes, piano keys, dental plates, shirt collars, and eventually the strips of film that would carry the first movies ever projected onto a screen. If the story ended there, plastic would be a curiosity, a footnote in the history of Victorian manufacturing. But celluloid was still, technically, a semi-synthetic material. It relied on cellulose from plants. Its supply was capped by the natural world. That changed in a Belgian chemist's garage in Yonkers, New York, in 1907. Leo Baekeland was a chemist who had already made his fortune selling a photographic paper to George Eastman for the equivalent of several $1 million in today's money. He did not need to invent anything else, but he was obsessed with a problem the electrical industry could not solve. How do you insulate the miles of copper wire snaking into every American city as the country electrified? Shellac, the traditional insulator, came from a bug in India and was becoming absurdly expensive. Baekeland took phenol, a compound made from coal tar, and formaldehyde, a nasty preservative, and cooked them under pressure in a stovetop vat he called the baccalizer. What poured out was a substance that could be molded while hot and then set, forever, as hard as marble. It did not burn, it did not melt, it did not dissolve in acid. It insulated electricity beautifully, and it had, crucially, no natural raw material behind it. It was, molecule by molecule, invented from scratch. He called it Bakelite, and it opened what historians now call the plastic age. Then came the accident that changed the 20th century. In 1933, two chemists at Imperial Chemical Industries in northwest England, Reginald Gibson and Eric Fawcett, were running a high-pressure experiment on ethylene gas. They opened their reactor to find a mysterious, waxy, white solid clinging to the walls. They had accidentally made polyethylene, the plastic that today wraps your groceries, lines your ketchup bottles, and, in fragmented form, has now been detected in more than half of every human brain sample tested in recent studies. Polyethylene turned out to be extraordinary. Lightweight, waterproof, cheap, chemically stable, and most importantly for its early users, invisible to radar. During the Second World War, British planes used it to insulate the radar cables that helped win the Battle of Britain. American industry cranked out nylon for parachutes, plexiglass for cockpit canopies, PVC for waterproof gear. By the time the war ended, the chemical industry had built an enormous production capacity for synthetic polymers, along with a nation full of trained engineers who knew how to work with them. And then peace broke out. The bombers stopped needing radar insulation. The parachutes stopped needing nylon. The factories, however, did not stop. They pivoted toward you. Toys, kitchenware, Tupperware, invented in 1946. Vinyl records, polyester shirts, the first plastic soda bottles, the first disposable diapers. In 1950, the entire world produced about 2 million tons of plastic. That was the total. Everything, everywhere added up. By 1970, it was 50 million. By the year 2000, it was more than 200 million. This year, according to the industry groups that track it, the world will produce something on the order of 460 million tons in a single year. Something like half of all the plastic ever produced by human civilization has been produced in just the last 2 decades. Take a breath, because this is where the story turns. By the middle of the 1970s, executives inside the American plastics industry had figured something out. They had a very serious problem. Their product, this miraculous molded stuff pouring off assembly lines from Delaware to Louisiana, refused to disappear. Metals rust, wood rots, glass shatters, paper turns to mud. Plastic just sits there in the corner of the field, in the ditch by the road, in the belly of a seabird, for what looks a lot like forever. A 1973 industry report, later unearthed by NPR reporters combing through archives at Syracuse University and the Hagley Library in Delaware, described the problem in flat terms. Recycling plastic was, in the language of the memo, costly, difficult, and technically infeasible at scale. There is no recovery from obsolete products, the report told executives, in exactly those words. A follow-up speech to industry leaders in 1974 was even blunter. There was, the speaker said, serious doubt that recycling plastic could ever be made economically viable. This is a very important moment in the story. The people who made the material knew before most of the people watching this video were born that the material would not go away. They knew before the first curbside blue bin was ever handed out. They knew before the little chasing arrows triangle was stamped on the bottom of a single yogurt cup. They did not tell you. What they did instead, starting in the late 1980s as the public began to notice the mounting garbage, was launch one of the most successful public relations campaigns of the 20th century. The plastics industry, through a lobbying group then called the Society of the Plastics Industry, spent tens of millions of dollars on television advertisements, on school curricula, and most crucially, on lobbying nearly 40 state legislatures to require the chasing arrows recycling symbol on every plastic container sold. Even on the plastics they knew perfectly well could not be recycled. Larry Thomas, who led that lobbying group for over a decade, told NPR the strategy in one plain sentence. If the public thinks recycling is working, they are not going to be as concerned about the environment. That is what the triangle on your yogurt cup means. Not that the yogurt cup can be recycled, just that someone in 1989 lobbied a legislature in a state you have never lived in to require the printing of a symbol that would confuse you enough to keep buying plastic. Fewer than 10 out of every 100 pieces of plastic ever manufactured have been recycled. Roughly 79 out of every 100 are sitting, right now, somewhere on the planet, mostly in landfills or in the natural environment. The Great Pacific Garbage Patch, that swirling mass of debris trapped in a rotating current between Hawaii and California, covers an estimated area more than 3 times the size of France. It is not a solid island. It is a soup, made mostly of fragmented pieces of the plastic bottles and fishing nets and packing straps and toys the world threw away, starting in the 1950s and never really stopped. And this is where the story finally arrives at your body. Because plastic does not disappear. It fragments sun and salt and wave action, and the digestive systems of small marine animals break it, over years, into pieces smaller than a grain of sand. Below that, into pieces smaller than a red blood cell. These are microplastics, and the smallest of them are called nanoplastics. In 2022, a team of researchers at Vrije Universiteit Amsterdam, led by the ecotoxicologist Dick Vedhak, ran a study on 22 anonymous Dutch blood donors. They were looking for polymer particles. In 17 of the 22 samples, they found them. Polyethylene from grocery bags, polystyrene from disposable cups, PET from the bottle you drank water out of yesterday. It was the first time in the history of medicine that plastic had been directly measured inside human circulation. A follow-up study, published in 2024 by some of the same team, found plastic polymers in 64 of 68 blood samples. Then in early 2025, researchers at the University of New Mexico published a bombshell in the journal Nature Medicine. They had analyzed brain tissue from autopsies performed between 2016 and 2024, focusing on the frontal cortex, the region behind your forehead that handles thinking and decision-making. They found nanoplastic shards in all of them. The concentrations in brain tissue were higher than in liver or kidney, and, most disturbingly, they were significantly higher in the 2024 samples than in the 2016 samples, rising fast. Journalists put the amount in a comparison you could picture. Enough plastic in the average human brain to fill a plastic spoon. Now think back to the beginning. $10,000 offered by a billiard company to save an elephant. An adult African elephant weighs roughly 6 tons. The total amount of plastic humanity has manufactured since 1950 sits at around 8.3 billion tons. Do the arithmetic. The material that was invented to save the elephants weighs, at the scale of cumulative human production, more than 1 billion elephants. 1 billion elephants of plastic on a planet that has only ever contained a few million actual elephants. That is the twist this whole story has been leading to. The miracle worked. It saved specific animals from a specific kind of exploitation. And then the miracle, without any single villain deciding it should, kept multiplying, kept lasting, kept fragmenting into pieces small enough to cross a placenta and lodge in the developing brain of a child who has not yet been named. Sit with that for a beat. Because everything that comes next depends on it. You are not going to fix this at the sink. Nobody is. The story of plastic is bigger than any household. It is a story about a class of molecules that were released into industrial civilization faster than anyone thought to build a way to catch them at the other end. Cleaning it up will take chemistry we do not yet fully have and political will several countries do not yet fully have. This is not something a browser tab is going to solve, but here is what the story does give you: a lens. The next time you hear a company describe a new technology as a miracle, ask the question no one asked in 1907. Where does this stuff go when we are done with it? Not in the marketing, not in the demo, in the actual, physical, 60 years from now sense. What happens to the substance, or the data, or the byproduct, when the world is finished with the current use case? That is the question the plastics industry never had to answer because the material worked so well that nobody insisted. Small practical things follow from the lens. Warming food in plastic containers releases more particles than storing it cold. Bottled water, according to a 2024 study out of Colombia, contains hundreds of thousands of plastic particles per liter, mostly shed from the bottle itself. Filtered tap water is not a lifestyle choice at that point. It is arithmetic. So is a cloth bag. So is a glass container. Not because any single swap will save the planet, because each one weakens the arithmetic on the other side. Go back one last time to 1863. To a small office in Manhattan where a billiard company posts an advertisement offering $10,000 to any inventor who can save an elephant. There is a chemist somewhere reading that ad and dreaming of a cleaner future. A future without ivory hunters. A future in which a child could play a game of pool without a tusk being harvested 3 continents away. He was not wrong. The future he dreamed of arrived. Ivory ceased to be the material of billiard balls. Elephants stopped being killed to make combs and piano keys and shirt collars. A whole ecosystem of Victorian luxury was quietly moved off the backs of the wild. He just could not see from where he was sitting the second consequence, that the very quality that made his invention miraculous, its stubborn refusal to break down, would be the quality that eventually placed it in the bloodstream of every one of his descendants. You are one of those descendants. You are also now one of the few people who knows the whole story of how the material got there, which means quietly that you are one of the few people in a position to ask better questions the next time someone announces the next miracle. The elephants got saved, and then something else needed saving.